We're busy in our series of linear equations and their adaptations, and today I'm dealing with vertically crossing lines on the Cartesian plane. What you can see here are two lines and they're crossing vertically. And we have an equation for line 1 and an equation for line 2. Now, we need to inspect the slopiness, or this m value, with that m value. First thing we do is we format all our lines as y is equal to mx plus c. The vertical intersect rule states the following. If the m, or the slope of equation 1, is the negative inverse of m, or the slope in equation 2, the two lines cross vertically. This is the vertical crossing rule. So, if y1 is equal to m1 times x plus c1, and y2 is equal to m2 of x plus c2, then m1 will be vertical to m2 if m1 is vertical to the negative of m2 to the power of minus 1. Let's look at this again. The vertical intersection rule states that if the slope of equation 1 is the negative inverse of the slope of equation 2, the two lines cross vertically. Let's look at a problem. The statement is draw a line vertical to equation 1 with y-intercept at 4. Equation 1 looks like that. Y is equal to minus 3x plus 3. We know how to draw that line by saying that the c part, 3, in other words, where the line crosses the y, is 3, and we'll draw that line. We know it's negative, so that must be hanging off to the left. We have a minus 3 y change for every change in x. With x changing by 1, y changes by negative 3. This is where we are. We have y is equal to minus 3x plus 3. We've drawn the line, and we've got the little triangle that we understand, which gives us our slope. For a vertical line, we must swing that triangle through 90 degrees. That's logical. If we swing that triangle around that point 3 where it's crossing the y-axis, or the y-intercept, the c value, we now draw a straight line along the same side as what it was. And we make the line cross the y at 4, because that's our problem statement. C is equal to 4. And we move our little triangle up. We now have a vertical line because we swung the triangle through 90 degrees and we drew a line on the same side as what it was. We now have a vertical line to y is equal to negative 3x plus 3. So, the first part of our equation is y2 is equal to mx plus 4. That's what we know. What is the new slope? What is the new m2? Well, we can look at it. We've got our triangle, and we now see that if the line is drawn in any direction, we have a plus 1 change in ny corresponding to a plus 3 change in x. So, our delta y over delta x, or our change in y over our corresponding change in x, a very important word, corresponding, is 1 upon 3. So, we have 1 change in y represents 3 changes in x, both positive. M2, or the slope of our second line, is 1 upon 3. We know the lines are vertical, and we can now write the full equation of our second line, or our vertical line. We have our two equations, y1 and y2, and they look like this. Let's evaluate the slopes. m1 is negative 3, m2 is a third. Now, let's look at them in a bit more detail. Our rule says that if m1 is vertical to m2 if and only if m1 is the negative inverse of m2. And if we can prove that equality, we know the lines must be vertical. We've already proved it by our little trick with moving the triangle, but let's carry on. So minus 3 is vertical to a third, if and only if we can prove that they're equal. But you know what? They are. Because if we take the third and we make it the inverse, and we multiply by minus 1 throughout the equation, quite legal, then we have 3 is the negative inverse of 3. Now let's have a look at this in a little bit more detail. Let's take the line moving from that point to that point. We clearly see that y goes negative 3 and positive 1. And that's why we have the negative inclination of a change in y minus 3 is a positive change in x of 1. And let's look at the other triangle, where we've gone through 90 degrees. And now all of a sudden we've swung the two values around. In our figure, the minus 3y has become a plus 3 of x. And the plus 1 of x has become a plus 1 of y. So, there we are. They are the negative inverse, and we've proved the rule. Let's look at this in a little bit more detail, because we need to get to an equality that we can actually understand properly in mathematical terms. There are our two equations. y1 is equal to minus 3x plus 3, y2 is equal to a third of x plus 4. Now, if m1 is vertical to m2, in other words, the lines are vertical, then we need to come up with a proof. And if you think about those two, then this is the rule. m1 multiplied by m2 is equal to negative 1. We've proven that. And if that's the case, then m1 is vertical to m2. That's all for today from Maths for You today. Subscribe to my channel, like or dislike the video, but if you put the warning bell on, you'll at least be told when the next video is available. Please go to https://www.mathforYouToday. That's our official site. There are many more benefits there, such as quizzes related to these and previous topics, and worksheets. And hey, think positive. Maths is great. You will be surprised at how enjoyable it becomes if you just practice a little and make sure you master some of these techniques. Thank you.